Good evening to all of you and welcome to Augmintech. So first of all, just let me know, am I audible all of you? Please give me reply in chat box fast. Yes, all of you, please give me reply. Am I audible? Okay. So all of you know that today this webinar is especially for cooling load calculation in HAB software. So that we'll discuss here. So first of all, we'll discuss the basic thing, okay, in heating and cooling load calculation. First, let's see what is heating load and what is cooling load. We'll discuss that. Then we'll start the, okay. But before starting, uh, first of all, we'll tell you about myself. Just remember here. See, myself, Mohammad Sajjad, and I am an mechanical engineer with expertise in MEP designing and modeling field. With several years of experience in industry, I have a deep understanding of the technicalities involved in MEP designing and modeling field. And I have done live projects like including residential, commercial building. Also, we have designed hospitals, building malls, retail shops, and more. So that's all about me in short. Now let's see, come to our main topic. Okay, so can we start now? Tell me, please, all of you. All of you are ready for this webinar? Just give me reply so we can start fast. Yes, without wasting the time, we'll start the webinar. So as I told you, before going to discuss in software, first let's see what is heating load. You know that we have two options, na? Heating load calculation, cooling load. First we'll see, actually this webinar is especially for cooling load calculation, we'll discuss here. So what is heating load? See, it is given here. Heating load is what? The amount of heat energy required to maintain the indoor temperature at a desired level during colder weather. That is called as a heating load. And here some component is given like what we have to calculate to find out the heating load. First thing, we need to calculate the heat loss through conduction. Means the heat escaping through walls, windows, doors, roof and floor. That heat loss we have to then we have to calculate the infiltration loss. Okay, because we know that cold air entering the building through cracks, gap or opening, and infiltration is what? Infiltration is the leakage of air inside the building through window cracks, gaps or opening. Okay, so we'll here in heating load calculation, we have to calculate the infiltration loss, heat loss through conduction, and the ventilation loss. Means the heat loss due to fresh air intake required for indoor air quality. Okay, so this is all about the heating load. Now, this webinar, as I told you, is especially for cooling load calculation in HAB software. So cooling load means what? All of you try to understand. Cooling load is the amount of heat energy that needs to be removed from the indoor space to maintain a comfortable temperature during hot weather. Okay, in summer season generally, what our main target is to find out the, suppose let's say, if you want to find out the capacity of any air conditioner unit, so first we need to calculate the cooling load value. Okay, okay. So here see, they have given here in the cooling, for to get the cooling load value, first of all we need to calculate the heat gain value through conduction. Means the heat entering through walls, window, roof and floor, that we have to calculate how much heat is entering. We know that in hot climates or in hot weather, what happen, outside temperature is high as compared to indoor, na? So outside heat will transfer inside the room. We know that the heat transfer concept, that heat will always transfer from high body temperature to low body temperature. So in summer season, the outside heat will transfer inside the room through walls, through window, roof, floor. So that all heat gain we have to calculate first of all. Then we'll calculate the solar heat gain, means the heat from direct sunlight entering through windows or wall, that we have to calculate. Then the internal heat gain, heat from occupants, lighting, electrical appliances, equipment, that we need to calculate, that the ventilation and infiltration gain also. Okay, then latent heat. So these are the points, or these are the parameters which we have to calculate, okay, for to get the cooling load value. Is it clear, all of you? Tell me, please. All of you understood what is actually cooling load and what are the parameters which we have to calculate to find out the cooling load value and the supplier CFM value? Tell me, please, fast. Give me reply so we can, don't be keep quiet like this. Okay, be active. So you will get enough knowledge. Yes, fast. Is it clear? So now directly we'll start the project here. First of all, here I have taken one small school building. Okay. So practically I will show you how we can calculate the cooling load and supply air CFM value. So can you see this is visible, all of you? Let me know. Here I have taken one project, let's say. So first let me know, all of you, this project, small project, just suppose, let's say this is your ground floor and one small school building. Okay. So whenever you will get the project from the architecture side, so first of all, what you have to do, first of all, just read the project carefully. Okay, what is your requirement, in which room you want to supply the condition air, and which room is a non-condition, unconditioned. So that all we need. So let's see, here the project is given, even the orientation is given. See the north orientation. So if this direction is north, so you know that opposite to that, here south, here east, and in the west direction. So if you compare this, suppose this is your north and east, so this is your northeast direction, northwest direction. Okay, so orientation also the architecture will give you. So here the direction is given. Even see, first of all, here we have a classroom 1. Can you see? In classroom 1, 5 to 8 ages students are sitting. Correct? Then next we have a classroom 2. Can you see? Here we have a plus 9 ages students are there in classroom 2. Office space is also there. Canteen, staircase and lobby area, toilet and OTS, open to sky. Okay. So this is our ground floor plan, let's say. And then next, this is our terrace floor. Let's say here we have only ground floor. Okay. Only one story building. So here directly we have a terrace floor. So what we have decided here, we have decided which type of unit you want. Okay. Which type of, before starting the calculation, first you have to do the selection. Na? Yes. So remember, based on the type, first our main target is just calculate the cooling load value and supply air CFM. As per that, we have to decide that which type of air conditioner unit we have to select, air handling unit, FCUs or what. So let's say, suppose I have decided to select the AHU. With the help of AHU, air handling unit, what I am deciding here, will supply the condition air in each and every room. So first of all, this information is important, in which room you want to supply the condition air. So this idea you will get from the client side. So let's say in our ground floor, we have classroom 1, classroom 2, office. So let's say I want to supply the condition air in classroom 1. Classroom 2 also we need to supply the condition air in office. Canteen is unconditioned space, let's say, and the lobby is also unconditioned space. Okay, and toilet is also, you know that it is also unconditioned OTS. So only this 3 room, classroom 1, classroom 2, and office. In this 3 room, I want to supply the conditioned air. So first of all, what we have to calculate for that? For classroom 1, what is our cooling load value in TR, ton of refrigeration, how much air we need to supply to maintain the comfort environment inside the classroom 1, or same way we need to calculate the cooling load value for classroom 2, for office. Okay, so the in this 3 room only we need to supply the condition air. So now let me know, is it clear up to here? And same way here, the soffit of slab of false ceiling height is also given. Suppose let's say in each and every room we have a false ceiling, and the false ceiling height from FFL, finished floor level, is 12 feet. Even the soffit of slab height means the bottom of slab from FFL, the height is given 15 feet. Is it clear? Soffit of slab you can say, or bottom of slab. So the complete room height is given up to slab level is 15 feet. False ceiling height is at 12 feet. So is it clear, all of you? So in this way, first of all, you have to read the project, okay, and then start the calculation. So up to here, anyone have doubt? Tell me fast. Don't be keep quiet. Be active. Again, I'm repeating. Fast, let me know, all of you, in chat box. Yes, give me reply, okay? Here, if you want to take interest in this webinar, so you should be active, okay? Then only you will get each and everything, okay? So now here, okay, I have told you that in classroom 1, classroom 2 and office. So first of all, remember before going to software, SOS means Sayyid Kasif, SOS means soffit of slab, or you can say bottom of slab. See, I will show you so you will get the idea here. See, some students have confusion. So suppose this is one section layout of any room, for example, any room, classroom. This is, I'm drawing the section, okay? Suppose here you have a slab, okay, concrete slab or whatever, and this is your floor, whatever thickness, 8-inch standard thickness, okay? Is it clear? So see, and inside the room, if you have a false ceiling, so just give the false ceiling. So the height is given, see, from FFL to this height is called as a false ceiling height, FCH. So in our situation, it is given 12 feet. And now from this point, see, this portion is called as a bottom of slab, BOS, or it is also called as a soffit of slab. Okay. So the height from FFL to this bottom of slab, our classroom or each and every room is how much? Given 15 feet, soffit of slab. Okay. And this is called as a FFL, finish floor level. And this is called as a top of slab, TOS, or you can say TOS or top of slab. Is it clear, this thing? Yes, tell me please. And this one is called as a floor grade level, and sometime it is called as a floor ground level. And the gap between the false ceiling and bottom of slab, this gap is called as a MEP service gap, or you can say SST, silver space tolerance. Okay. So hope now all of you understood about the soffit of slab is what. Okay. Okay. So now let's see. Come to our topic here. So here, this is our project. So see, before starting to calculate the cooling load value in HAB software, first thing now, always remember the first step is to prepare the space sheet. Here, we have to prepare the space sheet. What is a space sheet? See, here, I think this space sheet is visible for all of you. Okay. So here in this space sheet now, you have to write down the space, means in this space sheet, we have to enter the detail of each and every room, so that when we start the calculation in software, so we cannot go again and again in this project. So first of all, we have to enter the detail of each and every room, in which room you want to supply the conditioner. Like for example, in our case, as I told you, we are going to supply the condition air in classroom 1. Is it clear, this thing? So just in space sheet, you have to write down the name classroom. Space name is what? Classroom 1. 5 to 8 ages students are there. Na? So I have written here classroom 1, because in this classroom 1, we need to supply the condition air. So here I have written classroom 1, 5 to 8 ages student. Now I want the complete detail of this classroom 1. Okay, so first of all, come here in your project and let me know what is the area, because in space sheet now, because this all detail which we have to insert here in space sheet, this all detail will be used in the HAB software. Okay, that is why first of all, we are preparing the space sheet. So can you tell me the area of this classroom 1 in square feet? Tell me fast. See, it is very easy. This is your classroom 1. See the length of this classroom, 40 feet. Width how much? 30 feet. So 40 into 30 is how much? Tell me fast. Give me reply. Don't be keep quiet. Again, I'm repeating. So what is the area of this classroom 1? So from the layout, you will easily get the area 1200 square feet. 40 into 30. So here I'm writing 1200 square feet. Correct? Now we have to enter the gross wall area. Suppose exposure gross wall area. So can you tell me in your classroom one, do you have any wall which is which exposing directly? Do you have any wall which exposing to sun? Yeah, because here if suppose you have any exposure wall, so we need to enter the gross wall area of that exposure wall. So when you see in the classroom one, see this northwest classroom, I'm talking about classroom one, the wall which is exposing in northwest direction, see this wall is exposing directly. Even southwest direction wall is also exposing. Okay, simple. So first of all, let me know here. Okay, the wall which is exposing in northwest direction, I want the gross wall area. Gross wall area means the complete area, including the windows also. Okay, remember, if they will ask you the net wall area, on that time you have to remove the window area, but here in a space sheet you have to enter the gross wall area. Okay, so for gross wall area, can you tell me the wall which is exposing in northwest direction, what is the area of that wall? Gross complete area. See, 40 feet is the length, and complete height of this wall is how much? 15 feet. So 14 to 15, how much? Please let me know. Open the calculator and give me value, all of you, please. Yes, how much? Anyone have done? 40 into 15. So it is near about 600. Yeah, all of you are right. So here write down gross wall area which is exposing in northwest is 600. And when you see in your project, means in classroom one, we have one more wall which is exposing in southwest direction. So what is the area of that wall? 30 into 15. Yes, 30 into 15. 450 square meter. Am I right? Yes. Someone has written 609. From where you will get 609? 450. Now see the next wall which is exposing in southwest direction. The area of that wall is southwest. Sorry, 450. So here I have written the gross wall area of that wall. Simply, now in your classroom one, do you have any windows, glass window which is exposing? Yes, tell me fast. For classroom one, do we have any window? Remember, the space sheet is very important. So when you are filling the space sheet, please just read, enter each and every value carefully. Okay. So when you see here, the wall means here we have two window in northwest direction. See, each window area is also given length and height, width and height, 10 feet by 4 feet. So when you see in the northwest direction, we have two window. Each window area is 40 square feet. So 40 into 2, 80 square feet. Okay, total area. So open the space sheet, come here in northwest direction, write down what? 80 square feet. Is it clear? Yes, tell me please. Now again open the project and let's see. Two window we have in southwest direction also. And each window area is given 5 into 4 means 20 square feet. So 20 plus 20, 40 square feet. So here in a space sheet, southwards direction, write down 40 square feet. Is it clear? So in this way, you have to fill the detail. Now they will ask you for the roof, because here in our project directly we have a roof. Na? So what is the roof area? For classroom one, okay, same floor area is your roof area, 1200 only. Just write down 1200 square feet. Clear? Now, finally, now we have to enter the detail of partition wall, partition floor, partition ceiling. So before going to discuss what is actually partition wall, partition floor, partition ceiling, remember, partition wall means uh, the wall which is coming between condition and unconditioned space. That is called as a partition wall. The wall which is between condition and unconditioned space, that wall is called as a partition wall. Same way in case of floor, suppose if you have any floor between condition and unconditioned space, so that is called as a partition floor. Same way if you have a ceiling between condition and unconditioned space, that is called as a partition ceiling. So first of all, I want the detail for partition wall. So let me know for classroom 1, do we have any wall? For classroom 1, do we have any wall which is coming between condition and unconditioned space? Anyone? Yes. Okay. Where? Which wall? Tell me the name of that wall. Which wall is coming between condition and unconditioned space? Fast. Uh, no, I'm talking about the wall which is coming between. See, near the office, here we have a canteen. And even this lobby, because here in lobby area also we are not supplying condition air, na? So this is our unconditioned, this complete lobby, even the canteen is our unconditioned space. So when you see this wall from this point to this point, this wall is acting as a partition wall because this wall is coming between condition and unconditioned space. Remember, this wall is not acting as a partition because office space is also a condition. So the wall which is coming between condition to condition space, that is not a partition wall. Okay, so what is the length of this wall? Suppose the total is 40 feet. You can see here it is given. So I want the length of this wall, means I want the area of that wall, partition wall area. From this point to this point, suppose the office is 15 feet and total from this point to this point is 40 feet. So 40 minus 15 is 25. All of you know. Is it clear? So the length is 25. Height, always remember for the partition wall, always you have to consider the height up to the false ceiling level. Don't need to consider the height up to slab level. Why? The reason is what? Below the false ceiling only we are going to supply the condition air. Na? So heat will transfer, we know that. From the unconditioned space, heat will transfer into the conditioned space in classroom 1. So below the false ceiling only, na? So always the height which you have to consider for partition wall up to false ceiling level. So can anyone tell me? Tell me the area now. 25 into false ceiling height is 12. So how much area we have got? Partition wall area 300. Yes, right. So here I am writing 300. Okay. Square feet. Same way. Now tell me, do we have any partition floor? Here we have only ground floor and then finally terrace floor. So tell me, for classroom 1, we have partition floor. Again, I am repeating, partition floor means the floor which coming between condition and unconditioned space. That is called as a partition floor. Yeah, of course we have, na, Fahim. And yes, see, simply here below this ground floor, we do not have any condition space. Directly the floor is on the grade, na. So yes, you have to consider as a partition floor. This complete floor is our partition floor only, na. So and the area of that 1200. So I am writing the area here 1200. And we have any partition ceiling in our classroom 1? No. Why? The reason is what? Here actually, Realme, who is this? Just do not write anything, okay? Tell me now, we have partition ceiling here. No, directly we have a roof, okay? We do not have ceiling partition. Suppose, let's say, how you will get this idea when you have to consider the ceiling partition detail. Suppose, let's say, above this classroom, who is this Realme? Or just don't write anything, do not write anything, otherwise I will remove you, okay? Do not write anything in screen, just erase it fast. Suppose for example, this is your classroom 1, okay? Above this classroom 1, if you have any room which is unconditioned, so okay, on that time you have to consider the partition ceiling, okay, for classroom 1. Is it clear? Tell me please, all of you, clear or not? If you have any room above the classroom 1 which is unconditioned, so on that time you have to consider the ceiling partition detail. But here we do not have directly roof, so here don't need to consider, just write down 0. And finally, roof area already we have written because we have directly roof, okay? Now come here, about the internal load detail we have to enter here. First of all, the number of people. In classroom one, how many number of peoples you have? So remember the number of people based on the furniture, from where you will get the number of people. First thing, based on the furniture layout. If you have got the project in AutoCAD file from, no, we can't say like this 5 to 8. Okay, Mohammed Hassan. Remember, the number of people is totally based on the furniture layout. Let's say if in your AutoCAD file, architecture has given you the furniture layout also. So based on the furniture layout, you have to enter the number of people value. But let's say if the furniture layout is not given, so on that time, what you have to do? So you have to ask with the architect or interior decorator. If they will give you the information is okay. Otherwise, the last option which we have, as per ASHRAE ventilation standard 62.1, from that you will get the number of people detail. Okay. So see here, I have taken the screenshot of this ASHRAE standard ventilation. So this is the ASHRAE standard 62.12004. So in that, when you open the table 6.1, here you will get the minimum ventilation rates in breathing zone. So in this table, when you just scroll down, here you will get each and everything. So first of all, we are designing for what? Tell me, please. Classroom. Okay. So here you have to search it for classroom. When you see now here, classroom 5 to 8 ages students. So see in the second table, can you see in educational facility classroom ages 5 to 8? Even the CFM per person value is also given, means the outdoor air per person value. Okay. Yeah, and CFM per square feet value is also given for classroom ages 5 to 8. Even when you see here, occupant density is given. I will zoom it. See, can you see now? See, for classroom ages 5 to 8, occupant density is given, and here it is given for 1000 square feet. Maximum, how much number of people they have given here? You have to consider 25 for classroom ages 5 to 8 for 1000 square feet area. So when you come here, our total classroom area is how much? Tell me, please, fast. What they have given from the ASHRAE ventilation standard, we have seen for 1000 square feet area, maximum how much people we have to consider? 25. So our classroom one area is 1200 square feet. So for 1200 square feet, how many peoples? Let's say X. Do the cross multiplication, and from here, just calculate the X value. 25 into 1200 divide by 1000. Let me know the value now. Yes, fast. All of you just do the calculation. So here you will get near about 30 number of people, maximum, that much of number of. So if the detail is not given, people detail is not given. So from the ASHRAE ventilation standard, in this way, you have to calculate the number of people. Is it clear, all of you? Tell me, please. Anyone have doubts? So you can ask me without any hesitation. Yes, please confirm me. Okay. Now let's see here. So you have seen, so 30 number of people. So now, and what is the CFM per person value? Because that detail also we have to enter. Classroom ages 5 to 8, CFM per person 10, CFM per square feet 0.12. Okay. So now I'm writing that. See, in a space sheet, number of people we have got 30. Okay. CFM per person value, tell me how much? 10. And CFM per square feet value 0.12 from ASHRAE ventilation standard. Now the next thing, lighting load value. Next thing, we want the lighting load value. So okay, which type of room it is? Classroom one. In that we need to calculate the lighting load. So from where you will get the lighting load value? Remember, from the ASHRAE handbook, or if you have a ESHRAE handbook, so from that book also you will get the lighting load and this value. Okay. Even I think 1 minute, I will show you the exact from where you will get actually. Uh, just wait, all of you. We'll open the PDF file, then we'll show you from where exact you will get the lighting load value. Yes. Now let me know this PDF file is visible here. No, everything I will explain you in the end of the class, from how you will get, or in between the class, how you will get the recording and everything. Okay. So now first let me know this PDF file is visible, which I am showing you. Ashtray standard, ventilation standard 62.1. So first of all, just search it. Maybe in this standard it is given or not. I think now you will get for lighting load value, you have to open the in ASHRAE handbook, it is there. Okay, in ASHRAE or ASHRAE handbook, you will get. So that also I have both. See, here I'm opening the ASHRAE handbook. Let's say, suppose if you're working, ASHRAE is what all of you know. ASHRAE stand for Indian Society of Heating, Refrigeration, Air Conditioning Engineers. ASHRAE is the global society, American Society of Heating, Refrigeration, and Air Conditioning Engineers. So from the ASHRAE handbook also you will get, and from ASHRAE. See, tell me, is it clear? So I have collected the PDF file from to find out the lighting load value, because you all of you know that this PDF file, so it will take time to search. So here I have collected that some a screenshot, and then I will show you. Just see. First, let me know this. Now it is visible. This PDF file is visible in front of your screen. Yes, fast. Give me reply, all of you. So here I have collected some data here from the ISHRE handbook or from the ASHRE handbook. Okay. I will show you the reference also. Don't worry. Here you can see the outside design data is also given, from where you will get exact location. I will show you in the ISHRE or ASHRE both. Okay. This is the outside design data for each and every country. So in that, when you just scroll down now, here actually this is 15-page PDF file. In this PDF file now, you will get each and every detail for heat load calculation. Okay. So see here, one page will open that. See, can you see this thing? Non-residential cooling or table number 2. So in table number 2, when you see, this is our lighting power density using space by space method. Here common space type is given. Based on that, their lighting power density value is given in watt per square feet. So see, suppose let's say if you have a enclosed office, so how much lighting load we have to consider? 1.1 watt as per ISHRE or as per ASHRE. And let's say in classroom, because we are designing for classroom, na? So for classroom, when you see na, the for classroom or lecture or training room, the lighting load value is given 1.4 watt per square feet. So that you have to fit in Excel sheet. Clear? Here I am writing 1.4 watt per square feet. Now electrical load detail, remember we can't say exact, because remember this electrical load value you will get from the architecture side, because we don't know na right now which type of appliances or which type of equipment they are going to use in classroom. So that is why, as per thumb rule, suppose if you do not get the data from client side or architecture side, so better is what, as per thumb rule, always the electrical load which you have to consider is 1.5 watt per square foot for classroom. Okay, as per thumb rule, remember, because this detail you will get from the client side or from the architecture side. Okay, am I right? Tell me please, all of you understood this thing? Please give me reply. Okay. So here right now I have taken as per thumb rule. Suppose if any data is not given about the electrical load, so best is what? Just use the thumb rule, 1.5 watt per square feet. This is the safe. Okay. So this here we have entered the detail of classroom, each and every detail of classroom one. Same way you have to feel. Yes, who is Chaudhary? Just remove this. Do not draw anything. Okay, in this screen. Let's see now. Here, same way you have to fill for classroom 2 and for other room. So can you tell me for the classroom 2, now I'm just filling each and every, who is Chaudhary? Yes, will remove you. Okay. Just please delete this all lines and whatever. I cannot be able to delete. Okay. See, All of you let me know. Next, in which room we are supplying condition air? We have decided to supply the condition air in classroom 2 also, na? So we need the detail of classroom 2. And in classroom 2, we have a plus 9 ages students. Okay, remember. What is the area of classroom 2? Tell me, come here in the project. Tell me fast. Now, I think all of you understood. Tell me the area of classroom 1. Sorry, classroom 2. 900 square feet. Yes, you are right. Because see, how much long this room is 30 feet long and 30 feet wide, so 30 into 30, 900 square feet. Same way, just fill this detail fast here. 900. Now tell me, in our classroom too, do we have any exposure wall? Yes, of course we have. One wall is exposing in northwest and one wall is exposing in northeast direction. Yes, so the wall which is exposing in northwest, can you tell me the area of that wall? Gross wall area means the complete 30 into 15 feet. How much? 30 into 15 feet is how much? 450. So write down northwest, 450. Then one more wall we have in northeast direction, okay, which is exposing in northeast direction. So area 30 into 15, same, na? Here just change the northeast 450, same, correct? Now, for the classroom 2 only, I want to know, do we have any exposure window? Yes, or glass? Because this window is a glass window. Yeah. Of course, in both directions. See, one window we have in northwest direction, which is exposing in northwest direction, and the area 15 into 4 means 60 square feet. So just write down the window exposing in northwest, area is 60 square feet. Same way, two window we have in northeast direction. Each window area is 20. So two window 40. So the window which is exposing in northeast, the area of that window is 40. I have written here. Roof area is 900 only. Na? Now, can you tell me, in our classroom too, do we have any partition wall? Yes, fast. In our classroom too, do we have any partition wall? Yes. Yes, motor, you're right. Lobby or toilet wall. This complete wall from this point to this point, this complete wall, because we know that partition wall means the wall which comes between condition and unconditioned space. So here what we have decided, we are not providing any condition air in lobby area. Even in the toilet also, we are not giving any condition. This is the unconditioned space. So this wall which is coming between the lobby, toilet, so this wall is acting as a partition. So total area of that wall, can anyone tell me? 30 feet long. Height always for the partition wall, we have to consider the height up to the false ceiling level. 13 to 12. How much? 360. Am I right? Yes. 360 square feet. Just give the detail here, 360 square feet. Now I want the floor, partition floor detail. So same 900 only, na? And here also we do not have any ceiling partition. If you have any space above classroom 2 which is unconditioned, on that time you have to enter the detail of ceiling partition area. But here, if you see above this roof, classroom 2, directly we have a terrace floor, okay? Directly we have a roof, so don't need to enter the ceiling partition detail. Now, next thing, fast, number of people. So as I told you, the number of people value you will get based on the furniture layout, you will get the number of people. Otherwise, you have to ask with the architecture or interior decorator. They will give you this value. Suppose if you have not get the information from interior decorator architect side, okay. So the last option, as I shown you, what? As per ASHRAE ventilation standard. So here, just open the ASHRAE ventilation standard. Here I have taken the screenshot. We have a PDF file also. Okay, that also, if you are interested to see the PDF file, that also I am just showing here. Can you see this ASHRAE ventilation? In that, I think you have to open the page number, 1 minute. See, this my screen is visible, all of you, na? Clear? See, I think in page number 12, table number 6.1, minimum ventilation zone. Here, when you scroll down, you will get the classroom ages 9 plus. So for classroom age, Age 9 plus means what? Here in this classroom, plus 9 age students are sitting. Okay. So in that, when you see now, for 1000 square feet area, how much maximum people we have to consider? 35. So our classroom to area is 900. So if for 1000 square feet, number of people is given 35. So can you tell me for 900 square feet area, how much people we have to consider? Yes, fast. Yes, all of you, please, all of you be active. Give me reply fast. Some student are giving, what about other student? Azim is telling 25%, that is wrong. Yes, 32 is correct. Please try to understand. See now, if for 1000 square feet area, number of people is 35. So for 900 square feet, 32 only, na? 32, okay? Just check it. So now here I am just entering the detail. Let's see. For classroom 2, number of people is 32. Even lighting load is similar because this is also a classroom and I have shown you from the ISHRAE standard handbook that lighting load for classroom or for training room is how much? 1.4. And as per thumb rule, electrical load is 1.5. Now, can you tell me the CFM per percent value or CFM per square feet value for classroom? 0 to how much? So see, same. Again, for that, you have to open the ASHRAE ventilation standard, means 62.1. Here, when you see for classroom age 9 plus, CFM per percent 10 and CFM per square feet 0.12. Same. Okay. Just enter that detail 10 and here 0.12. Okay. Hope all of you understood. Now, one more space is there in which we have decided to supply the conditioner. Which space? Office. Can you see? In office space also, we have decided to supply the conditioner. So I want the detail of this office area. So can you tell me the area, total area of this office? 20 feet long, 15 feet wide. So 20 into 50 is how much? Total area of office is 300 square feet. 1000 square feet, Christopher. From where you have seen 1000? 300, na? See, so here write down office and area is 300. Now, can you tell me, do we have any exposure wall? Yes, Abdul Wahab, please just remove this, whatever you are drawing. Just do not do anything, do not write anything in the screen, okay? Because it will disturb here. Okay. First, yes, we have. Okay. From where? See, I'm opening the project and let's see. This is our office area. So in office, as you told me that we have exposure wall. So you can see one wall is exposing in southwest direction and one wall is exposing in southeast direction. So I want the cross wall area. Yes, tell me. The wall which is exposing in southwest direction. What is the gross wall area? 20 into 15. No. Length is 20. So height is 15. So 20 into 15, 300. Okay. So the wall which is exposing in southwest direction, 300 square feet area. Total gross wall area. And one wall is exposing in southeast direction, total area 15 into 15 to 25. And direction is southeast, where it is 225. Okay. Same way, when you see in our office, do we have any exposure windows or exposure glass? Yes. See, one glass we have in southwest direction. When you see now, in southeast direction, we do not have any glass. Can you see? This is a complete bricks wall. But here in southwest direction, we have one glass. Area of that window is 20. Okay. So here what I am doing, see, southwest 20. Correct. And roof area for office 300. Correct. Am I right? Tell me please, all of you. Is it clear? Now tell me partition wall detail. For office, do we have any partition wall? For office, do we have any partition wall? Yes, see this The wall which is coming between canteen or between lobby, this complete wall is acting as a partition wall. Correct? So the total length of this wall is 20 feet. Height you have to consider up to the false ceiling, 12. So 20 into 12 is how much? 240. 20 into 12 is 240, na? 240 square feet. Okay. So here I am writing the partition wall area is 240 and partition floor area is 300. We do not have any ceiling, just leave it. Now number of people I want to find out the number of people. So okay, open the ASHRAE ventilation, ASHRAE standard 62.1. Here first of all you have to see the occupancy category is office, na? Just scroll down in the next table. Office building is given, in that office space. So when you see for office space, even the CFM per person value is also given 5. CFM per square feet values 0.06. And you can see for 1000 square feet area, how much maximum people we can consider for office space? 5. Our area is how much? Our office area is 300. So if for 1000 square feet area, number of people is 5. So for 300 square feet, how many people we have to consider? 2 members. Yes, 2 people. Where we have considered full height instead of 12 feet. Yes, tell me. For exposure wall you're talking about. Yeah, I don't know your name. 705480. Yes, tell me. Where you have confusion? See, no, for exposure wall, we have to consider, see, the wall which is exposing to sun, to completely the heat will enter from outside to inside to complete wall, na? So that we have to consider the complete wall only. Okay? Okay. So now let's see here, first of all, 5. So 2 number of people. So here I am entering the detail. Let's see, first of all, number of people is 2 and lighting load value is how much? So I will show you the lighting load value from the ASHRAE. I think from ASHRAE or ESHRAE standard, both. In both standard, you will get the table. Can you see this table here? See, for office space, they have given the lighting power density value, lighting load value 1.1 watt. Okay, remember this thing. For office space, 1.1 bar. So here I am writing 1.1. Now electrical load as per thumb rule, just take as a. And what is the CFM per person? 5. And CFM per square feet 0.06. I have shown you from the ventilation ASHRAE standard 62.1. Okay. So in this way, in which room you want to supply the condition air? So we need to enter each and every detail of that room in the space sheet. Okay. That is why we are preparing the space sheet. So once if you have prepared the space sheet, so it is very easy for you to start the work in software. Okay, because don't need to go again and again in project and see what is the area and everything. So that is why we have collected all the data of each and every space here. Okay, so hope up to here all of you have clear. So if anyone have doubts, so you can ask me, please. Anyone have doubts, so just please ask. Someone is asking me, sir, in the partition board, why do we not consider door? Where we have door? Tell me fast. Where we have door? Here also we do not have any door in this. Okay, you're talking about this door. Yeah, you are right. We have to remove the door area. Yeah, you're right. In that case, we have to, huh, because here proper problem is what, na, door is of different material. Okay. So, okay, you have to remove the door area. Because see, if suppose your wall is of bricks material, so the heat will transfer through bricks inside the room, so that will be different. And when you go for door, suppose if door is of wood material, so the heat will transfer through this door may be different. Okay, Yeah, you are right. See, that I will show you, yeah, how much actually now how much heat will resist by the bricks wall, that is different. And the heat resist by the door material like wood material, that is different. So okay, you can go it, no problem. Okay, now is it clear? Okay, so this all detail means resistance detail means suppose the heat, all of you know the heat always transfer from high body temperature to low body temperature. So in this case, suppose this is your partition wall. So we know that the heat will transfer from lobby area to the classroom one through this bricks wall. So how much heat will resist through this bricks wall, that I will show you. So if you have a wood material, like if you have a door which is made up of wood, so how much heat will resist by the wood, that is different. See, that I will show you here in this PPT because I have that detail. Can you see this? 1 minute, huh? All of you just give me time. So we'll show you the detail, how much heat will resist by the bricks materials and everything is given. So when you open the ASHRAE or ISHRAE handbook, in both you will get this. Okay. So can you see my, sorry. Yes, please. My screen is visible. First, let me know so we can start after that. Okay. Now see, here the material, here some materials I have taken from the ASHRAE standard. You will get, if you have a different material, you can go through that, okay? Because some of the material, like for example, if you have a bricks wall. So for bricks wall, see the conductivity is also given, resistance value is also given. Resistance is so the bricks wall will resist how much heat? 0.2 square feet degree Fahrenheit hours per BTU. So based on the thickness, let's say if you have a 4-inch bricks wall, so 4 into 0.2. So that much heat will resist by the bricks wall. Same way if you have a wood material, so that is different one. Okay, so that is why you have to consider, yeah. So remember all of you this thing. So here we have prepared the space sheet. Actually, here in webinar, we do not have that much of time to discuss each and everything in detail. Okay. Here we have only 2.5 or 3 hours. So that is why we do not have that much of time to discuss each and everything in detail. So for that, if you want to go in detail about each and everything, so you have to join with us in live class. Okay. In live class, we are teaching each and everything in detail. And anyone, if you are interested in our live class, you want to join with us in our complete HVAC design and drafting course, or let's say if you want to do the complete postgraduate program in MEP design and drafting, so you can join with us. See, you can visit our website. We have see augmintech.com. In that you can see here the postgraduate program in MEP designing and drafting. In detail, we are teaching each and everything. See, the program highlight is given here. What you will get here, we have a live classes for 6 months, total 2 hours, more than 2 hours, I think. Access to recording, you will get the access to recording for 1000 day. Even will give you the, here will give you, will discuss the 12 plus MEP software, like for duct sizing, we have a macro sizer. Same way, we have a 12 MEP software that also will discuss access to class note means PPT for 1000 day. Even 500 plus interview practice question will provide you 100 plus file to download, like handbook, data, catalog, Excel sheet, whatever I am using in the live class, that all will share you. You can easily download that file. Okay, then internship and job assistance certificate of completion. Okay, this all detail. Even if you want to go in more detail, suppose what, how you will learn and what you will learn, what is the syllabus. So when you scroll down here, see each and everything. HVAC design complete hours is given here, about 56 hours. Here, if you want to see the topics, which topics we are going to cover in HVAC designing, so see here different topics is written. Okay, here the topics which we have written in short. Okay, everything will cover here. Cooling load by using O general, manual, Excel sheet, HAB software, everything, winter load calculation. Okay, this all plenum box and everything, even the ventilation, each and every part. Same way in drafting, the topics we cover, that is also given in AutoCAD software. Even in the plumbing, see the topics which we'll cover, that is given. So from here you will get each and every detail. Okay, so if you are interested, so you can contact us, you can visit our website, or I will share you the contact number also. If you have any doubt or you are interested in course, so you can contact, okay, in the given WhatsApp number. See, I'm sharing one WhatsApp number, so you can visit. If you have any question or need further assistance, so feel free to reach out to the given WhatsApp number. See, in your chat box, I have shared the WhatsApp number. You can contact with this given WhatsApp number. Okay. And next thing, many of students are asking for the recording. So remember, recording is not free. We'll provide you the webinar recording also, today webinar recording, even the completion certificate. But remember, that is not free. So for that, you have to pay $10. Okay. So here I'm also in group. I'm sharing the link, payment link. So to access the lifetime webinar recording and completion certificate, you have to make a payment of $10 using the link which I have shown in the chat box. So once the payment is confirmed, so the course access link will be shared with you within 24 hours. Okay. So if anyone are interested for the recording, for this webinar recording or completion certificate, so for that, you have to just given a link already I have shared you. Just go through that. Okay. So now come to our main topic here. What we are talking about here. See, here we have completed the first step. What are that step? Here we have prepared the space sheet. Now, once if you have prepared the space sheet, now open the HAB software. Here, see, I have opened the HAB software. So can you tell me my software is visible of all of you? Tell me please fast. So here just hit on OK. And finally, when you see, 1 minute. Okay. Let's see. So when you open the HAB software, you will get this type of interface. Just hit on OK. Okay. So see, they will ask you, already we have some project. If you want to open the existing project, so hit on open. Okay. Otherwise, if you want to create a new project, so here generally we have to create a new project. So hit on new. Clear? So now they will give you here the ventilation standard, which is inbuilt in the HAB software. Their standard is given as standard for ventilation 62.12007. So always from the list, you have to select the latest one. Okay. Energy standard, just go for latest one from the list. Okay. So these are the things which you have to select. Now, in general, see, the unit system is given. So leave it as it is and finally hit on OK. Now tell me, this screen is visible here? Yes, fast. Okay. So now what you have to do, first of all, when you have opened the software, here when you see the first option is given untitled. So first of all, you have to give the project name. What is your project name? So for that, simply just select this untitled option, right click. So you will get one option, properties. Hit on that property and give the project information here. What is your project name? Yes, fast. Tell me. Suppose let's say, uh, just give, because here we have a school building. So school building already I have saved one project. So I am giving education building. Let's say education building. Our project name is what? Let's say education building. Here number, any number, just 001 I have given. Date, today date, they will take today date automatically. Contact name, if you want to give contact type, some non-technical data is given, just fill this. Okay. Then finally hit on OK. Now see, once you have given the project name, so that project name in place of untitled, you can see the project name is given, educational building. After that, the next thing which you have to do is what? Here, come here in the weather. Hit, when you select the weather, see the weather properties is visible here. Double hit on this weather property. Now here you have to fill the weather properties. Means project detail. You have to give the project detail as per your location, for which location you are performing you are calculating the cooling load, for which location, your project location exact, as per that you have to give the detail. So can you tell me here, let's say, suppose for example, I am designing for any just let's say Hyderabad. Okay, I'm designing for Hyderabad city, which is in India. Okay, so for that, if you are designing, suppose your location is Hyderabad, which is in India. So as per that location, we need the complete detail. Means what is the latitude, longitude, elevation. So see, the data source is also given. See, for example, in region, I have selected Asia Pacifics. Location, okay, go through that. India. Okay, so in India, some city by default, some city is given in HAB software like Ahmedabad, Bangalore, Calcutta in India. Okay, but suppose let's say if I have some other city like Hyderabad. Hyderabad is also in India, but Hyderabad is not given in this list. So if you are selecting suppose anything, any city from this list, so automatically na the HAB software will take the value of will give you the value of latitude, longitude, elevation, and the data from where they have given this value from the ASHRAE 200 ASHRAE handbook. But let's say if you have any city which is not given in the list, so for that simply just type Hyderabad. If you have a Hyderabad city, just type Hyderabad. Now see, the data source is given user modified. Now you manually you have to give this each and every value. Latitude of Hyderabad is what, longitude, because Hyderabad city is not there in the list. You have manually type that city na. So manually, you have to write down the latitude, longitude from the ASHRAE or from the ISHRAE, which standard you are following. So yeah, here I will show you. See, as per ASHRAE standard, from where you will get this total detail like longitude, latitude, and everything. So first, let me know this PDF file is visible. This here I am using the 2000 latest version, like 2021 ASHRAE handbook. So from this ASHRAE handbook, you will get the detail. So in this, just scroll down. I think when you see in the table of content, na, here also you will get the idea. Open the table of content. See, can you see in the table of content, chapter number 14, climatic design information is given in chapter number 14. So open the chapter number 14. In that, you will get the climatic design. See, can you see here? Yeah. Yes, all of you, let me know. Screen is visible na clearly. Please don't be keep quiet. Yes, no. So here you can see you will get each and every complete. From here you can select the complete location. See, first of all, from here it is started. So when you see the United Station is given, United States of America. Under that, whatever city, okay, that is given. Based on that city, the latitude, longitude, even the elevation, heating dry bulb temperature, cooling dry bulb temperature, mean constant wet bulb temperature. See that all detail. But our location is what, Hyderabad, which is in India. So just scroll down, open the India is where, just 1 minute, huh? Actually, here the complete world detail is given. Uh, just wait, all of you, give me time. So here, when you see the next station will be, uh, it's gone. No, no, see na. Next Utah, then whatever country, Washington, okay, West Virginia, Canada, under Canada, whatever type. So just scroll down and let's see. See, then we have Algeria and India. Now you will get here. See, Brazil, different countries, China. So below that, I think India we have. See, Egypt and France, Germany. See, can you see the India country? So under this India, see each and every city is there, Ahmedabad and whatever. So we are designing for Hyderabad. So you can see here the location is given Hyderabad, Begumpet. As per that, you will get the latitude. See, here I am minimizing just little bit. See, tell me all of you can visible na this Hyderabad, Begumpet, and here you can see the latitude is how much? 17.45 degree north. Can you see? Longitude is given for Begumpet 78.46 degree east. Elevation is in feet. Okay, remember, I think in which unit elevation? 1742. Okay, I think it is in feet only, na? Actually, here they have not given unit for elevation. So, okay, maybe here anywhere. See, feet. It is given here. So, elevation value is given, means the height from sea level. How much for Hyderabad Begumpet? Tell me, please. And when you see here, one more detail which I want to show you, which is important here. Can you see the cooling dry bulb temperature is given here in this cooling dB slash MCWB. So dB stand for dry bulb temperature. Okay. Or you can say the ambient air temperature measured by the standard thermometer. And MCWB means what? Mean constant wet bulb. Okay. Means the average wet bulb temperature absorbed when the dry bulb temperature is at its specified percentile. So that is given. And here see the percentage is given a 0.4% dry bulb, mean constant wet bulb value 1%. Okay. So remember this percentage represent the frequency of occurrence of extreme weather condition. Okay. 0.4% dB mean constant wet bulb means what? Outdoor condition that are exceeded only 0.4% of the time during the cooling season. 1% means condition. It means what? Condition exceeded 1% of the time. 2% means the condition exceeded 2% of the time. Okay. So here the question is, sir, which value we have to consider? Suppose I want the project detail. For Hyderabad location, I want to find out the dry bulb temperature. So when you see this is our Hyderabad Begumpet, for cooling dB, I want cooling dB and mean constant wet bulb. But here we have a different value. When you see for 0.4%, it is where dry bulb temperature is 105.9 degree Fahrenheit. For 1% dry bulb temperature is 103.8. For 2% dry bulb temperature is 101.7. So here many of students have confused that which value we have to consider. So remember 0.4% is basically used for critical facility. Example, data center. If you're designing data center, hospital, clean room. So on that time, you have to consider the dry bulb temperature or wet bulb value 0.4%. Okay. Where system failure or inefficiency during extreme heat is unacceptable. So for that, 1% commonly used for commercial and residential building to balance system sizing and cost. So, okay. So in our case, always the dry bulb temperature and mean coil wet bulb temperature, you have to select for 1%. Okay. 1 not 3.8 and see the wet bulb temperature is what? Tell me fast. 71.5. As I told you, 1% commonly used for commercial and residential building to balance system sizing and cost. And 2% is used for project where cost efficiency is prioritized over performance during peak condition. On that time, we'll have to select. So here in our case, always remember, just go for what? Tell me 1%. And let me know the value, please fast. 103. See the dry bulb temperature is because this all detail we have to enter in our HAB software. So first we'll start from the latitude 17.45. 17.45 degree north. So let's see here. I am entering the value 17.45 manually. Longitude is how much? Tell me fast. when you see the longitude is 78.46 east, 78.46. Okay. So write down. Can you tell me the value which we have to enter here in minus or in plus? Longitude value here we have to enter because 78.46, I think something it is there. So plus or minus, tell me. Yes. Anyone? Minus why? The reason. I want the reason here. Okay. If you know is okay. Otherwise, see, I will show you here. So here, 1 minute. Huh? Mm, just wait. Just give me time. Okay. We'll show you this detail. I think it is there or not. Space sheet. Mhm. So remember, here actually that is why I'm telling now. Will take will take time. Okay, everything is not possible here to show you. So remember, here in detail, will in live class will teach you. So here, finally, the value which you have to enter in the HAB software. Where is software? So now tell me, my screen is visible, all of you. The software is visible or not? Tell me fast. Yes, please give me answer. Okay. So if it is visible, see here the longitude value when you see na in ASHRAE handbook for Hyderabad is I think how much Hyderabad Begumpet is 78.46 east. So minus you have to consider minus 78.46. 78.46. Okay. Elevation, tell me fast, please. Help me fast. 1742. Okay, elevation is 1742 feet. So here I'm writing 1742 feet. Design drivable temperature. So can you tell me the summer design drivable temperature, this cooling dB? Oh, is how much? 103.8. 103.8. 103.8. And this one 71 means summer constant wet bulb is what? 71.5 na? Am I right or not? Tell me please. Yeah. Next thing, summer daily range. See, daily range is what? Daily range is the difference between the maximum and minimum temperature in a given day. Okay. So that is also given in ASHRAE handbook. For Hyderabad, when you see na, the daily range is given or not, I think it is not given here. So, but we can easily calculate na in a given day. Oh, 32.3 you are telling. Actually, it is not correct. From where? Actually, it is, but where it is, daily range value is given anywhere. Okay, if it is not given here, I think 1 minute. We'll see first of all. No, daily range value is not given. Okay. So in ASHRAE, if it is not given, no problem. So when you open the ESHRAE standard, see, in ESHRAE, they have given the detail. Just open the eShray. I hope that all of you can view this. In eShray, when you open the page number, this one, can you see? Here also we have outside design data. See like this. Page number 1.5, whatever, ASHRAE HVAC data book. Here see the design embed drivable temperature consider wettable. Here also same way based on the city. But this here you will get only the India's, the city which is in India because it is Indian standard. Na? And here, when you scroll down, as per your city, you will get the daily range value also, everything. Okay, but I'm searching for Hyderabad. So can you tell me anyone for Hyderabad? 1 minute. Daily range value. First of all, search it. Hyderabad AP. A daily range. Here also it is not given, na? But when you come here, see Hyderabad. City Hyderabad. 1 minute, huh? Hyderabad is where? Yes. 1 minute. Hyderabad is here. Gwalior, Guwahati. Then below that, we have a Hyderabad city. No, actually, here, na, we can't do that. Guwahati, Rajkot. See now, here you will get the detail of each and every station like Vishakhapatnam, Varanasi. Just wait. Exact, I will show you. Rajkot, Hyderabad. I'm not getting it. No, I think near about na the daily range for Hyderabad is 14 degree Fahrenheit. So from Ishre you will get, okay. Right now I'm writing 14 degree Fahrenheit. In outside design is not given na daily range value. That is why for each city they have given in detail. Here see, they have not given the daily. For each city, when you see na, scroll down, they have given the based on the city, Ahmedabad monthly. Here monthly wise maximum minimum temperature, even the daily range value is also given. So for Hyderabad generally I think I have seen 14 degree Fahrenheit. Okay, so just write down the daily range. Daily range is what all of you understood na. Yeah, maximum difference between the maximum minimum temperature in a given day. Winter dry bulb temperature, tell me fast now as per ASHRAE. uh, Winter dry bulb, here I am opening the ASHRAE handbook. Yes, fast all of you. So see the heating dB 56.1, and here also we have a two option 96%, 90%. Just go for this 156.1, okay, dB. So now enter 56.1 here, 56.1, and winter constant wet bulb also we want. So how much we have to consider the winter? Yes, anyone? Wet bulb temperature is how much? Yes. So better, yeah, that is why in Ashray handbook you will get, yeah, that is why I have collected the data in one PDF file because it will take time. Okay, so you can see from the Ishray I have taken this outside design data. So here you can see in the Andhra Pradesh, Hyderabad, each and everything. See in the winters 55 near about dry bulb, because this data I think I am showing you 2021 and this data may be the little bit older version. That is why here when you see in the winter the dry how much it is showing Hyderabad 55, a wet bulb 48. Okay, is it clear? 55, just take as a 55 48. Okay, 55 48, let's say 48 and 55. Is it clear? So these are the detail which you have to enter. Tell me please, all of you clear this thing, how to enter the complete project detail in HAP software with the help of ASHRAE or ISHRAE. Now, same way, now when you see here, we have some more detail like atmospheric clearance number. So what is this actually? So see, I'm showing you. Atmospheric clearance number is a factor used to correct clear sky solar radiation profile for usually clear or hazy condition. Okay, so here they have given, here one detail is given that ACN, atmospheric clearance number values typically range from 1.15 for very clear condition to 1 for typical condition and 0.85 for very hazy condition. Which type of condition you have? Okay, so let's say I am assuming 1 for typical condition. So go for 1 value by default value which is given. Now next thing, the average ground reflectance value. So what is this average ground? Right now it is 0.2. So first try to understand the average ground reflectance defined how much solar radiation is reflected by ground surfaces surrounding the building. Okay. So the typical value is given based on your surface type. Which type of surface you have? New concrete. So the reflectance value is given. Old concrete, bright green glass, crushed rock. For crushed rock, see, if your surface type is crushed rock, so reflectance 0.2. So let's say I'm assuming crushed rock type. So as per that, the value we have taken. Correct? Next thing, the soil conductivity. So their detail is also given. Soil conductivity generally refers to the thermal conductivity of soil surrounding a building. See here, based on the types of soil, like which type of sand, if you have what you have. Screen is not visible. Tell me. The screen is not visible. Yes, all of you. Soil conductivity I am explaining. So why? Acha. Okay. See, I'm talking about the each and every this soil conductivity actually. Here, see the sand. If you have a sand, normal range is given. Recommended value for design they have given here. Okay. For silk, for clay. So right now from here, I'm just see, I'm taking the default value for this one. Okay. So I'll kind of 0.8. Correct. Same way design CLG. When you see here, design the next design CLG calculation month. So what is here? What you have to do? Just let's see first. What is design CLG? See, design CLG means design cooling calculation month. Okay, it is given. This item defined the range of month consider when performing cooling design. Means in which month in your location, for example, you are designing for Hyderabad. So in Hyderabad, in which month you will feel more hot? Anyone can tell me? Let's say from, I'm just writing from May to July. If you know the exact data, so as per that, you have to write down the design CLG calculation month. Okay. Now time zone. See for time zone, how much time zone we have to consider? Tell me, please. See, here it is given. This item defines the difference between local standard time and Greenwich mean time in hours. Okay. See, some time zone is given for Central, for Eastern, for Mountain, for Pacific. So what we have to select? Tell me. Yes, fast. How much we have to select the time zone? Pacifics. For Pacific, how much it is given? GMT plus 8 hour. Tell me please, any one of you. GMT plus 6 hours. Central. Huh, you can select it. So by default value, I'm just taking whatever it is given. Okay. So go for that. Okay. Why you are telling minus plus 6 we have to select? Yes. Okay. Just go for that. Now here see daylight saving time, I just leave it no. Okay, after doing this all, see based on this design parameter which you have entered here, you will get the design temperature monthly wise. Can you see? In January in Hyderabad, maximum drivable temperature is what? Minimum drivable temperature, wet bulb temperature, maximum, minimum. So monthly wise report it is there from January to the December. Can you see? Same way, hourly detail view also you can see from here. See, this is the January month, but we know that in Hyderabad, generally when you see na, in which month we are feeling more hot, the temperature is in July or August. Can you see? So here, just change the month. If you want the hourly detail of July month, just from here, just change the, open the July where it is. See, here July. So in July, when you see hourly detail view is given, like in 12 a.m. midnight, the dry bulb temperature is 92. In 1 a.m. 91 point something. Means when you come here, na, so see at what time the temperature is high in July month. I think in 3 p.m. Can you see? In 3 p.m. afternoon, we have a temperature 103.8. Okay, based on that design solar, okay, simulation, everything you will get. So finally, just hit on OK. After filling this weather property, it is very important. Just hit on OK. So once you have filled this weather property, see the design. Okay, right now I have not selected the simulation city that I will discuss in the live class in detail. Okay, here you have to select the simulation city also for Hyderabad. So just enter the value. Now, after entering this, next is what? Project libraries. Okay. Next, hit on project libraries. And here we have to prepare the schedule first of all for lighting, electrical, peoples. So how to prepare the schedule? Select the project library, double hit on schedule. Now you will get one option, new default schedule. Okay. So what you have to do, double hit on new default schedule and let's see the schedule type. So which, first of all, I am creating the schedule for people. Okay. So I have written schedule name people and people will comes under fractional. You can see. So, okay, select it. Check fractional. Now come here, hourly profile. Now here, if you want to create the profile, so that also you can create. So profile one, suppose I am creating profile here. Okay. So here I'm creating profile number one. I have selected. Just open it from here. See. Now, can you tell me in your school building, education building generally? So here you can see our hourly wise profile you can create. So suppose first of all, I am giving the name a working day. Working day. First, I am creating the profile for working day. So can anyone tell me in a school building, suppose our educational building or school building, working time is suppose from 8 a.m. morning up to 4 p.m. for example. So here what you have to do first now when you see the hourly wise profile is given 00 means 12 a.m. midnight time, 01 1 a.m., 02 2 a.m., 3 a.m. up to see 11 p.m. Can you see all of you? Tell me please. Okay. So here suppose if your working day or working time, let's say working day, you can say for school building, suppose the school building will your school will start from 8 a.m. morning up to 4 p.m. Okay, 16 p.m. So for that, the before that up to 7 p.m. we do not have any like people's are there is no people na inside the school building before 8 a.m. So just select this profile manually also you can do, otherwise here write down from zeros to uh 07. So automatically the profile is selected. Here we do not have any people in morning from 12 a.m. to 7 a.m. We do not have any people inside the classroom. Okay. So just select 0%. Automatically see. And we have students in the schools or people from 8 a.m. to 4 p.m. Okay. So here just write down from 8 a.m. to 4 p.m. 100% people we have. After that, from uh, after 4 p.m. like 17 means 4 p.m. to 23, 11 p.m. We do not have any people inside. So just select that and write down 0. Correct? So in this way, you have to create profile for working day. Let's say double hit on people. And now if you want to create one more profile for holiday, let's say in which day you have a holiday. So that also I'm just writing holidays. Okay. And I'm creating the profile. Just hit on that for holiday. Can you see? So we know that in holiday generally tell me, in which day, suppose let's say in holiday, do we have people inside the classroom or in a school building? No, na. So select from 0 to 23. We do not have, just give me 0%. Okay, there is no people. So in this way you have to write down. And remember one more thing after writing this all. See, double hit on people. Here we have created the hour for working day. We have created the profile. Now come here in assignment. Here also you have to give the detail. See, in school building, working day is how much? Monday, Tuesday, Wednesday, Thursday, Friday. Only we have a Sunday. In Sunday we have holiday. Okay. Here we have created two profile. One for working day. So select this complete up to Saturday and place it in. Just select this working day profile. So automatically 1111 you can see, because working day is our first profile. So here it is shown. This is a working day. Now Sunday, suppose let's say Sunday is holiday. So select this Sunday and hit on this holiday profile. So automatically see, because here we do not have any people inside the room. And suppose let's say if you have any other, because you know that only, not only Sunday we have holiday, we have, suppose if any festival, so at that time we have also holiday. So select it and place it in holiday profile. Okay. In this way you have to do. Is it clear, this thing? Tell me please, all of you. Yeah, am I right or wrong? Tell me fast. Okay. So hope all of you clear this thing. In this way, you have to create the profile for people. Same way, double hit on new default schedule. I am creating the profile for lighting. Same. So working day, you know that. So hit on lighting fractional. Okay. And double hit on lighting. Same hourly profile. First of all, you have to select the first profile for working day, create one profile for working day and create one second profile for holiday. Okay. So in this way you can do, otherwise see what you can do, just right click, delete this one. What you can do to just duplicate lighting, right click, duplicate and give the name as lighting profile. Now I am creating, because everything is same. Hit on fractional, hourly profile in working day. We know that the light will be operate from 8, because the class will start from 8 to 4 p.m. So on that time 100% lighting load I am considering. Okay, in holiday there is no light uh, will on, so that is why. Okay, clear? Same way, in this way, just right click, create duplicate, write down create for equipment. So equipment profile already we have created. Hit on this one fractional. Okay, everything is same. Okay, then right click, duplicate for electrical, create one schedule for electrical. Okay, then create one schedule for sensible heat, sh. Clear? Now for latent heat, right click, duplicate and write down latent heat, fractional only. And then create one more schedule. Just right click, duplicate for fan and thermostat. So fan and thermostat. I have given the name here, thermostat. So for that, in schedule type, select the fan, or and everything is same profile and everything is same. Okay. Only these changes you have to do. Okay. So in this way, you have to prepare the schedule for lighting, equipment, electrical, fan and thermostat, latent heat, sensible heat, people. Clear this thing. Now come here, wall. Just double hit on new default wall. Now you have to fill the wall properties. So which type of wall you have? Because see na, fan and thermostat will comes under that only na. When you are creating the schedule, see new schedule. So whatever we have enter people, when we are creating the schedule for people, lighting, so that will comes under fractional, and fan and thermostat is not under fractional, na, separate. So that is why schedule type I have selected fan and schedule. It is simple. Come here for wall, hit on double. Now which type of wall? Wall assembly name you have to write down here. Suppose let's say outside. If you know the exact detail of wall, as per that you have to write outside wall. Suppose I have given. Now, outside surface color, always better is what? Select the dark color. Why? While designing for safety purpose, always select the dark color, because the dark color absorptivity is given 90%. Means dark color surface. We suppose if you have a wall outside wall, color is a dark color. So that dark color will absorb more heat, na? So while designing, we have to consider that more heat is transfer from outside to inside the room. As per that, we'll get the cooling load. See, when I'm selecting light color, their absorptivity is given 45%. Medium color 67%. So just go for dark color. And now from here, you have to select the R value, which is very important. So first of all, now just remove this, right click on this point and remove it. Only right click, remove. Only one row I want. Here you have to select inside which type of wall you have. Your wall, suppose if you have a 8-inch, 4-inch wall, suppose let's say I'm assuming we have a 8-inch lightweight concrete block. Okay. Wall detail, if you know the exact detail, as per that you have to select it here. As per that, see, they will give you the density, specific heat, even the R value. And but problem is what? Our main target is on U value. U value is what? U value, or it is also called as the overall heat transfer coefficient. Okay. Overall heat transfer coefficient. So U value for wall, how much? So this detail you will get from the ASHRAE or ISHRAE standard. See, I'm showing you. Can you see this? My PDF file is visible, hope. So here, when you open this table number, this one, overall heat transfer coefficient, U value for building construction. So see, which type of wall you have. Based on that, you in summer, the U value is given. U value is simple. U value define that how much heat will get transferred through wall, roofs. Okay, so that detail. So suppose I'm assuming we have a masonry wall, 8-inch concrete block, no finish. So for that, U value is 0.49 BTU per hour square feet degree Fahrenheit. Okay, 0.49 na, 0.49. Remember this thing. Okay, open your software. But here in our case, can you see the U value is 0.329. Okay, no problem. If you want to increase the U value, but directly when you are selecting, it is inactive, grayed out. Okay, you cannot do the changes. So if you want to do the changes in U value, so better is to go change the R value. R value is what? Resistance. U value is inversely proportional to R value. Okay, means when you reduce the R value, automatically the U value will increase. Suppose let's say I'm selecting 1 and hit on this U value. Now see, they will give you the value 0.49. Okay, in this way you can just select it. So near about it is coming 0. If you want exact 0.49, so select 1.05 and just check it. Okay, it is not showing. So 1.07. Hit on that. No. Okay. 1.01. Now you will get exact, na? Tell me. Hi, yeah, of course, Muhammad Hassan. If you have a different, like suppose if you have a yes, air gap or other resistance, for example, for you are using like thermocol, for example, to resist the heat. Okay, so no problem. Here it is, so manually you have to go for manually. Okay, manually calculation. Here in the software, maybe which type of wall you have, it is not given. So you have to calculate the U value manually, and whatever you are getting, so from here you can arrange by changing the R value, you will get the U value. Okay, so here I'm just selecting, suppose. So as per that, we have got how much? Tell me, please. 0.49. Understood, na? Tell me, Hassan. Clear? So as manually calculation you have to do. Actually, in designing, in our live class, we are teaching this all, okay, in detail, how to calculate the U value manually. If you have different types of like air gap, you have a plaster, let's say. So how to calculate plaster will resist how much amount of heat, bricks wall will resist how much. So finally, we'll get the U value. Once you have calculated the total resistance now, so we know that U is inversely proportional to R. So you will get the U value. As per that, will write down your value. Okay, after creating this, just hit on OK. Finally, now same way you have to create, hit on roof, double hit on roof, and suppose for roof dark color, I have selected, remove this layer. Which type of roof you have? Okay, let's say here, just take any one. If you know the exact data, so that is better for you, but here we don't know. So I'm selecting 18 lightweight concrete block. Okay. So if you want to see the roof here in the ASHRAE also, see for roof U value you want to check. So we have a different type of roof. You can see roof ceiling. So under that, see 8-inch lightweight concrete, no insulation. So see there U value 0.08. So okay, you can manage it by changing the R value. See, right now R value is 2. If you are increasing the R value 10, so automatically the U value will reduce. Okay, because both are inversely proportional to all. Yes, Atikur Rahman, remember here I am telling now, I have shown you just directly from the ASHRAE. Exact U value you will get, you have to do the manual calculation. Okay, if you know the resistance value in ASHRAE, it is given everything. In webinar, everything is not possible to cover. Okay, see now 11 when I'm entering the R value 11. So as per that U value near about 0.06. Okay, just hit on OK. Same way, just create for window. Hit on window, double hit. So which type of window you have? Suppose here I am writing windows. Write down the height. So remember in HAB software, you can enter up to 2 window in one wall. If there is 2 window, okay, is it okay? Otherwise, see, I'm showing in spaces when you come now and hit on this window. So can you see here, all of you, let me know. In window, walls, windows, door detail, see only the window in each face of wall, only 2 window we have. Suppose let's say in case if you have more than 2 window, on that time what you have to do? Okay, in one wall, if you have up to 2 window, okay, on that time it is clear. But let's say if you have more than 2 window in one, like the wall which is exposing in northwest direction, we have 3 window. So on that time, so remember, so here you have to use one trick. Trick is what? See, I'm showing that trick which you have to use. In our case, we have only 2 window na, in each face, each wall face. So you can enter directly also. But let's say if you have like this, suppose here I am writing the quantity. Okay, suppose the window quantity is 3, for example. And now width of that window is what? Tell me. Then height. All of just 1 minute. Huh? Here, just erase this. Then I will show you. Just all of you see here. Here we have to use one trick. Okay, what is that trick? See, if you have more than 2 window in one wall, so what you have to do? Quantity, width of window, height, okay, then area. Let's say the first condition, let's say, suppose you have 2 window, quantity 2, each window width is 5 feet, let's say height 4 feet. So total area is how much? 40 square feet, correct? And you can write like this also, or even you can write in place of quantity. If I write down the area directly and in place of width and height 1 so then also the area is 40. So this trick you have to use if you have in one wall, let's say the wall which is exposing in this direction northwest, for example, and you have more than 2 window, suppose 3 window. On that time you have to use this trick. In place of width and height, just write down 1 and in place of quantity, write down the total area. So I am using this second trick only. See, so you will get the idea here. See what I am doing. All of you try to understand. Just hit on window, double hit on window properties. Here, window, I am writing the names. In place of height, 1, width, height, 1, and overall U value for window. So see, open the standard, this. All of you can visible this thing. Tell me. Here, when you see na, overall factor for solar heat gain through glass is given. Which type of glass you have? Suppose let's say I'm assuming ordinary glass. So as per that, the different criteria is given. If you have an ordinary glass, so light color, medium color, or dark color, what, let's say light color. So for that, the solar heat gain value is given 0.56. Okay, that value I'm entering here in software 0. Oh, sorry, 1 minute. Huh? Overall factor for solar heat gain. Okay, 0.56. Okay. So here write down 0.56. Now overall shade coefficient. To calculate the overall shade coefficient, we have a formula, means SHGC value. Okay. But overall U value we want here, na? And we are seeing the SHGC value. Sorry, this is our solar heat gain through glass, na? So for U value, you have to come here. See, here we have a different vertical glass you have or a horizontal. Let's say vertical. Double pan, single pan or triple pan. Suppose I am assuming half-inch double pan. So for that, see, U value is given 0.55. So that you have to enter in software 0.55, correct? And now to calculate the shade coefficient value, we have a formula SHGC value divided by 0.87. And we know that SHGC is 0.56, means the solar heat gain coefficient divided by 0.87. You will get 0.64 value. Okay. As per that, you have to fill this detail. Okay. After that, door, if you have any exposure door. So in our project, if you see in classroom 1, classroom 2, we do not have any exposure door. All of you can see. Let's see, I'm showing you in our project. When you see now, we are supplying, we need to supply the condition and classroom 1, 2 and office. So do we have any exposure door here? No. If suppose, let's say, if you want to supply the conditioner in lobby area, on that time for lobby, you have to consider this door is a exposure. But here in our case, there is no exposure door. We have one double door exposure, but that is for lobby area. Na? In lobby, we are not supplying conditioner, so leave it. Okay. So here in our case, we do not have, so don't need to create don't need to enter the properties of door. Same way, if you have given window shading, if you have given the shade, so that detail also you have to enter here. Shading geometry properties, write down shade name. Okay, hope all of you just understanding this all. Okay. See here I have given the shade name. Now reveal depth. What is the depth? Okay. So for that you need the complete detail. Then only the shade is, see, reveal depth is what? Everything I will show you here. See, reveal depth. Reveal refers to a window which is set into the wall of a building as shown in the figure below. See, reveal depth means they are asking for this depth. Okay, the window, this is your glass window, from this window to this outside edge wall. So what is your depth? So if you know the detail, so then only it is possible to fill. Okay, so right now I'm not using because we do not have any detail. Okay, so after creating this schedule, wall properties, roof and all, now you have to come here in these spaces, double hit on new spaces, and here write down the space name. Like for example, first space we have a classroom 01, 5 to 8 ages students are there. Na? Tell me, please, all of you are visible this screen. So in spaces, you have to enter the detail of each and every space. So can you tell me the floor area? Already we have prepared the space sheet. In that the floor area is 1200. Average ceiling height of classroom 1 is 12 feet. Building weight, this detail you will get from the structure people. So right now just consider the default value 70 pound per square feet it is given. Now space usage. So from here you have to select the space education classroom 5 to 8. As per that, when you select the classroom, as per that, see the outside air requirement. CFM per person value 10, CFM per square feet value is given 0.12. If you remember, I have shown you in the S-ray 62.1, same value we have got for classrooms. So by default, the software will take from, because here this ASHRAE standard 62.1 is interconnected with this software. So you will get, only you have to select the space. As per that, they will give you the CFM per person, CFM per square feet value. So after completing this general, come here in the internal. Now overhead lighting, which type of fixtures you are using, which type of light inside the room, inside your classroom one, which type of light, recessed type or free hanging type. Recessed type, if you have, suppose, let's say we are using recessed type. So vented or unvented. Remember, what is the difference when we have to select the vented, unvented? I am using recessed type of light, for example, in our project. Okay, let's see. I will show you the recessed type, how it will look. Can you see this light? recessed type. So in recessed type of light, now generally the light blast is above the false ceiling. Okay. Now we have two options, recess vented or recess unvented. So see, try to understand. Recess vented, suppose when the return air touches the light blast. When return air touches the light blast, on that time you have to consider the recess unvented. And when return air does not touch the light blast, directly enter into the AHU. So on that time recess vented. So in our case, let's say we are using return air duct, okay, which is connected to the diffuser, return air diffuser. So if you see above the false ceiling, the light blast, because when the return air touches the light blast, so automatically the heat, extra heat will add up, and again that return air will go into the AHU. So on that time, but here in our case, I am assuming we have return duct. So return air will return from the space through duct, and we are supplying to the AHU. So what we have to select, recess vented or unvented. When return air does not touch the light blast, so recess vented. What is the wattage? See, actually for repeat that I will show you repeating everything after that. First, let's see, okay. Here we do not have that much time also, na? So that I will explain you, don't worry. If we get the time, so I will show you that. So first let me know up to here, is it clear all of you? See, when we have to select the recessed vented, when the return air does not touch the light blast, on that time we have to test recessed vented. And when return air touches the light blast, on that time recess unvented. But here we are using return air duct. So the return air does not touch the light blast, directly enter into the HU, just go for recess vented. What is the lighting load? Tell me, please. 1.4, I think. Okay, blast multiplier, 100% heat will add up. Just go for the, and in the schedule already we have created schedule for lighting. Select the lighting. Task lighting only you have to select when, let's say in showroom, you are designing for showroom where we are using lighting for a specific area. So on that time, task lighting detail is needed. Here in our case, we are not using any task lighting. Electrical equipment wattage is 1.5. And in schedule already we have created the schedule for electrical, selected. Number of people for classroom 30, I think. And activity level, which type of work in classroom? Like office work only, na? Just go for that as per that sensible latent heat. And here in schedule, select the people. Miscellaneous load is what? Yes, any one of you. Please. When we have to consider the miscellaneous load, remember the heat generated by non-electrical equipment. That is your miscellaneous load. And remember, for kitchen, remember, miscellaneous load only you have to consider, suppose if you are supplying conditioner in kitchen, laundry area, because in that type of area, na, the extra heat will also add up. So on that time means the heat, so in kitchen area, if you have any equipment, different types of equipments are there, na? So extra heat will add up. So on that time we have to consider the miscellaneous load. But in our project, we have a simple classroom. Don't need to go for miscellaneous. Come here now. We have to enter the wall detail. So can you tell me for classroom 1? All of you please be active and let me know. For classroom 1, what is exposure wall detail I want for classroom 1. So from where we get, see, already we have prepared the space schedule if you remember. Okay, clear all of you? So see, for classroom 1, if you see now here, um, one wall we have in northwest direction and one wall in southwest direction. Northwest 600, southwest 450. Okay. 600, 450. So here select the exposure northwest direction first of all and southwest. Na? Am I right? The wall which is exposing in northwest 600 square feet area and southwest 450. Correct? And as I told you, in place of window, in place of quantity, you have to write down the total area of that window. The window which is exposing in northwest, what is the total area of that window? Fast 80, and the exposing in southwest 40. 80 40, correct? So here I am writing 80 for south northwest and 40 for, okay. But remember, don't forget in the window you have to select, because already we have created, enter the properties of windows. So select the properties. From here, select the windows, correct? If you have any exposure doors you have created, you have entered the properties of doors. So on that time, okay. So after doing this detail, after adding this detail, in classroom one, we do not have any exposure board. So I have not entered the door quantity and door properties. Come here in roof or skylight. Directly here we have a horizontal flat roof, their area, everything. If you have a skylight, just write down the quantity. And here you have to create a new skylight. Means here you have to write down the detail width and everything. Okay. Same as I shown you in window. Is it clear? Then finally, here in infiltration, just write down design CFM value. Means infiltration is what? Remember, infiltration is the leakage of air inside the building through window crack, door opening. Okay. So means how much air will infiltrate through window cracks, or let's say if you have a gaps or opening. So through that, you know that the outside heat will transfer inside the room. Na? So how much air will, so that we have to, for that we have a complete calculation. Okay. I will show you here. You can see this. I think my PPT is visible. See here we have a different method to find out the infiltration CFM, how much air will infiltrate through window cracks or door opening. So see, formula is given here. By crack method, you can easily calculate window CFM is equal to crack length into leakage rate. So for window, let's say if you have one window, through window, how much infiltration rate is given? 0.357. So for that, we have a complete calculation. You can see, for example, here two window is given. Okay. Each window is of 7.5 feet wide and height 5 feet. Let's say just calculate the air infiltrate. How much air will infiltrate through this window? So simple, first you need to calculate the perimeter. Okay. So calculate the perimeter, simple 2 length plus width, simple I have written here. Correct. 50 total we have got. And we know that infiltration rate of window is how much? From ASHRAE we have taken 0.37 CFM per feet of sash crack. Okay. So here total we have 15 feet. So as per that, how much we get? Tell me. 18.5 CFM. Mean the air will through this window, the air will infiltrate how much? 18.5 CFM air will infiltrate. So that air will add up extra heat inside the room. Okay. So for that, we have a complete calculation. Okay. As per that, so right now I'm just writing 0.5. Suppose, let's say this CFM, I have got 120. Okay. If you are giving heating, so okay, that part. Infiltrate CFM, I'm assuming 120 CFM. So when you enter 120, now automatically they will give you the CFM per square feet ACH value. Okay. System will give you. Yes. Am I right or not? Tell me, please. Now come to floor. Which type of floor you have? So tell me in our classroom, which type of floor we have? Floor above unconditioned space also you can select, or slab floor on grade, both condition. Okay. So in our case, if you see now, we have a floor directly on grade. So select this option. If you have floor, suppose your classroom one is above unconditioned space. So on that time, no need to enter additional no additional input is needed. Okay. If you have a slab floor on grade level, so on that time we need to enter. So in our case, tell me which condition is there. Floor classroom one is above unconditioned space or directly on grade only, na? Third condition is satisfying. So just select it. Floor area is 1200, floor U value. Okay, so floor U value you will get from here. Same from the table ASHRAE. Here I will show you U value. Just go for that. See, for floor, wall we have seen for partition. See, ceiling floor. So here the condition, suppose let's say we have a concrete floor. So can you tell me in our floor classroom, heat flow up or heat flow down? Always the heat transfer from high temperature body to low temperature body. So suppose if you have one floor, let's say. So can you tell me, all of you? Yes. Fast, give me reply, all of you. Heat will flow up or down? Up, yes, of course, because ground heat will enter the inside the room, na? Because you know that outdoor temperature is high as compared. So heat flow up and their value 0.34. Okay, U value. So just enter here 0.34. Correct? Now they will ask you for exposed perimeter. If suppose you are using any insulation in floor to resist the heat, so R value is needed. Okay, right now suppose we are not using any insulation, just leave it. Exposed perimeter is what? Let's see, all of you, how to calculate the exposed perimeter. So when you see, this is our classroom one. Here we have one floor whose thickness, let's say the floor thickness is 8 inch, total length is 40 feet. That is exposing, na? And here we have floor of 30 feet, thickness is 8 inch. Okay, so how to calculate? See, all of you, listen carefully here. How to calculate the exposed perimeter? So for that, simply here I'm drawing one floor is exposing in northwest direction like this. Suppose the thickness 8 inch. In feet, how much? I think 0.67 feet. And the total length 40 feet. This floor is exposing in northwest direction, correct? So calculate the perimeter. P is equal to 2, the 40 plus 0.67. How much? Tell me, please. 40 plus 0.67 into 2. 81.34 feet, correct? And one floor we have in southwest direction like this, whose length is 30 feet. Okay, but the thickness is same. Let's say I'm assuming 8 inch, 0.67. Now calculate the perimeter. 2 into 30 plus 0.67. You will get 30 plus 0.67 into 2. It is near about 61.34 feet. Okay, so the total perimeter is how much for classroom 1? Exposed perimeter. Yes, please, fast. 61.34 plus 81.34 is near about 142.68. Let's see, 143 feet. Okay, that is our total exposed perimeter. Okay, hope all of you understood. Yes, 143. So here I am writing in software, open and write down the detail. 143 exposed perimeter. Okay. After writing the floor detail, now come to next partition. So we have partition, wall partition we have na in classroom 1. Just hit on wall partition. What is the area? Total area of that wall partition. Open your space sheet because already we have written in space sheet 300 square feet. Okay. So now 300 square feet, write down the area. And U value for wall is how much? Partition wall. So that you have to open the table ASHRAE. From here, just see partition wall is given. Which type of wall? Suppose 4 inch, no insulation, no finish, 0.4. Okay, just here I am showing you directly, but in detail we have calculation for that. And now they will ask you unconditioned space maximum temperature. So what is the maximum temperature? Unconditioned space maximum temperature. Ambient temperature is how much? For Hyderabad we have considered. Tell me. I think any one of you, how much ambient temperature we have considered for Hyderabad? If you see na, 103.8 we have considered. 10, am I right? 103.8. Just 104 consider. Ambient temperature is 104. And unconditioned space maximum temperature, how much? As per ASHRAE, should be 76°F near about we have to maintain inside the room. Just leave it. Ambient temperature at space minimum temperature means in winter minimum ambient temperature. So it is 55 only, na? And unconditioned space minimum temperature in winter is how much? Suppose uh, in winter season, outside temperature is 55 °F. So when you come inside the room, so what is the temperature? Little bit more than outside or less than in winter season? In cold climate, I am talking about. So how much? Tell me, please. If ambient temperature in winter or cold climate is 55 outside, so inside the room, the temperature will little bit, huh, little bit high. Okay. So how much high? As per ASHRAE, 5 °F. So just take as a 60. Okay. If you have a ceiling partition, so in the second partition, select ceiling and write down the detail. But we do not have in classroom, just leave it as it is. After filling this detail, hit on OK. Now same here I have filled the detail of classroom 1. Same thing. Now you have to enter the detail of classroom 2, floor. How to enter? Don't need to go for again hit on no default. Just right click in classroom 1, duplicate, and just change the name and everything whatever you want from here. Okay. So you will get. Is it clear? Now once you have created this space, come here finally in the system tab. Okay. In system tab, when you see in system tab, new default system, double hit on which type of system. Let's say AHU we are using, system VAV system, variable air volume. Again I am repeating here, I do not have any that much time to discuss VAV and CAV is what. Remember, in short I am just showing you VAV is what? Variable air volume. Okay. So if you are using VAV, so you can vary the airflow rate, but the temperature is constant. CAV system is the constant air volume system. In that, the airflow rate is constant. You cannot vary the airflow rate, but temperature will be varied. Okay. Airflow rate is constant, but the temperature, you can vary the temperature. So if you are using VAV system, so remember, you can easily vary the airflow rate. Okay. So here I am using VAV equipment type from here. Suppose chill water air handling unit, just select it. Air system type is VAV. So I am going for VAV. And remember, the number of zone is totally depends on the VAV box. So in our project, we have 3 rooms. We need to supply the condition air in 3 rooms: classroom 1, classroom 2 and office. Let's say in each and every room, we need to place the VAV box to control the airflow rate. Let's say for in any room, so temperature level will be down, because we know that as per ASHRAE standard I have written also the how much temperature we have to maintain for human comfort, near about 76 °F. Due to any reason, let's say the temperature will down inside the room, the temperature down or increase or down, let's say it will become 60 °F. So on that time now, the thermostat which you have placed inside the room, so that detect and give the signal to the VAV box to just. VAV is simple. Here we have a damper inside the VAV box that will open or close as per your airflow rate requirement. Okay. So number of zone is totally depends on the number of VAV box. So for each and every room, I'm using separate VAV box. So I'm writing 3. But here only we have designed the first classroom 1 only. So just write down 1 only, because I have in spaces, we have created these spaces only for the classroom 1. Na? So write down 1 zone for classroom 1. Come here in the system component. Here supply fan or duct system. So heat gain value, duct heat gain 10%, consider duct leakage, just consider as a 5%. Now in supply fan, which type of fan you are using, okay, their configuration, total static value. Right now I'm using 2" of water gauge. Okay, that you have to enter the detail. And then finally in the zone component, what you have to do, just write down your VAV 01. Okay, and select this space, add it. Same way, if you have a multiple space, you are using separate VAV box for that space. So write down the VAV2 and select the different space. Okay, right now we have created only spaces for ground classroom 1. So that is why I have selected that. Finally, in thermostat, select thermostat, and here already we have created the schedule. Just select that. Okay. Now in sizing data, safety factor always 10% for cooling, latent cooling, sensible. Okay. If you are giving heating, okay. So 10% for heating. Okay. These are the detail which we have to enter and then finally hit on OK. Now see, here you will get, now if you want to see the result, right click, print or view design result. All of you can see this screen is visible. So here what you want to see, system sizing summary. So from the table, just check it. Whatever you want to see from the table, you can check it. Load summary. Okay. So here I have selected system psychometric, zone sizing, system sizing summary, system load summary. If you want to see the space load summary, check it and see the preview first. Yes. Right click. Just directly print input data first. See, they will ask you to where you want to save this, which you are printing. Let's say in desktop with the name, what classroom, na? Classroom 01. Save it in desktop. Now I will show you. See, in desktop now you will get that PDF file which I have saved. So can you see? This file is visible. All of you let me know, please. Here you will get each and everything. See here, whatever name you have, system you have selected, now everything is there. Even zone component, see the classroom, uh, supply data. Here the supply airflow is given, equipment data. See, I will show you in detail. Actually, our main target is to see the space load. Na? Just see. Open the software. Right click on the system. Print or view design. It's result. Just hit on that. Just hit on preview. Now, can you see the preview here? Before that, first see the preview. Here, whatever, add system sizing. Actually, the main thing, open the second page. This is your first page. To open the second page from here, hit on that. See, zone terminal sizing, even the zone sizing data is given. Our main target is space, load, and airflow. So for classroom one, can you see the cooling sensible value we have got? 59.8 MBH. So you can easily now convert it into TR, because 1 TR is equal to 12 MBH, mega BTU per hours. Okay. So if I want the value in TR, so 59.8 divided by 12 is how much? 4.9 TR. Okay. So here the cooling load value which you have got is how much? Tell me please. For classroom one, the cooling load value is what? 4.98 means near about 5 TR we have got. And the supply air CFM means 2950 CFM air we need to supply to maintain the comfort environment. So in this way, you have to calculate the heating and cooling load and supply air CFM value. Okay. So this is the procedure. Now the next thing which I want to explain you here, remember, again I am repeating, if you are interested for this webinar recording or completion certificate, so for that it is not free. You have to make a payment of $10. I am sharing you the payment link also in your see chat box. Check it. So once the payment is confirmed, the recording and the completion certificate recording access link will be shared with you, okay, within 24 hours. So if anyone are interested, so you can just buy it from here. Sai, I have told you na, 1 TR is equal to 12 MBH. Okay. If you have a converter software, so with the help of that easily you can get the idea. Yes, of course. Mirab, as per this data, I have only shown you for classroom one. Same way, you have to calculate, you will get the heating and cooling load and supplier CFM value for classroom to office area. As per that, the total load value you will get. So as per that, you have to do the equipment selection. Okay. So here I am sharing the, because many of you maybe they are interested to buy, to get these. So if you want the access, the lifetime, to access the lifetime webinar recording and completion certificate, just you have to make a payment of $10 only. And I have also shared the payment link. So once you have done the payment, so you will get the access link within 24 hour. We'll share you the okay. Yes, tell me. So you have only last 10 minutes for this. Okay, all of you. If anyone are interested, so you can buy it from here. Just payment link already I have shared. Okay, so you can use this payment link, make a payment, and you will get the access. Link will be shared with you within 24 hours. Okay. So you have a last 10 minutes for that. If anyone are interested, so you can just take it. Otherwise, no problem. Okay. And if anyone have doubts, so regarding this, suppose if you are facing any problem during the payment, okay, so I'm sharing one WhatsApp number also. If you have any queries or you need further assistance, so just contact into the given WhatsApp number in the chat box. You can see I have shared. Okay. Clear? So if you have doubt, so regarding this payment or whatever, so you can contact into the given WhatsApp number. So last 5 minutes is there. If anyone are interested, so you can do the payment, you will get the access. Okay. Last 5 minutes are there. So just do it fast if anyone are interested. Yes, last 5 minutes are there. Harishankar, I have told you if you want the access link for video. So for that, what you have to do, okay, please make a payment of $10. Then only you will get this. So I have shared the payment link also. Once the payment is confirmed, so you will get the access. A link will be shared with you within 24 hours. Okay. Last 5 minutes. So last 2 minutes are there, all of you. So if anyone are interested, so you can just do the payment. You will get the access, okay, within 24 hours. Yes, and if anyone have doubt regarding this payment and enrollment process, so you can contact into the given WhatsApp number. Already I have shared, you see. If you have question, any question or need further assistance, so for that, see, I'm sharing you the WhatsApp number in chat box. You can use it. So last 2 3 minutes are there. So if anyone are interested still, so you can contact. So okay, so now the time is gone. Okay, all of you. So hope all of you enjoy the session. So see you in the next webinar. Goodbye and thank you for all of you to attending this webinar.